Hello friends, welcome to my YouTube channel. This is Assistant Professor Ramdas Pandit Bharsat. In this video lecture, we are going to study about neutralizations curve, or we call them titration curves. In this case, you can see here a plot of the change in concentration of H plus ions or pH as a function of the titrant, that is burette solution. Added is known as neutralization curve or titration curve. If you are doing acid base titration, in that we will add base into the acid. So whatever the pH changing graph you will get, that graph is nothing but the titration curves. So we have to see in detail about the curves with the help of some terms. That the first one is endpoint. Endpoint means, you can see here, point at which the indicator changes its color during a titration is called endpoint of the titration. For example, you can see these two indicators. If you are doing titration by using methyl orange indicator, so in that titration you will get endpoints only between this pH transition range, that is 3.1 to 4.1. Okay, and if you will use the phenolphthalein indicator in that titration, so you will get endpoint in that titration between this pH transition range, that is 8.3 to 10. Okay, now we have to see the next term, that is equivalence point. In this case, see the point at which exactly equivalent quantities of acid and base added to one another titration, or the equivalence point of the titration. In a titration, if you are adding same volume, same concentration of solution, acid base, so you will get neutralization, okay, or equal addition will be there. For example, you can take 25 ml of 0.1 normal HCl and 25 ml of 0.1 normal NaOH. You can see HCl gives 1 H plus ions, okay, and this NaOH takes only 1 H plus ion, and you can see the volume of HCl is 5 ml and NaOH in 25 ml. Again, you can see concentration of HCl is 0.1 normal and NaOH having the concentration is 0.1 normal. So you can see here both are equal. Okay, concentration is equal, volume is equal, and the strength is also equal. Okay, now see second case, 25 ml of 0.2 normal H2SO4, and here 50 ml of 0.1 normal H. And in this case, you can see H2SO4 we have taken, so which having different strength as compared to HCl. Okay, so and you can see the concentration also change. So that's why to neutralize the 50 ml of 0.1 normal NaOH, 25 ml 0.2 normal H2SO4 is required. Okay, you will get the times both are equal. Okay, so like this we can add both acid and base solution, equal amount, equal volumes, that times you will get equivalence point. And the next term is neutralization point, and in this case you can see the definition of neutralization point, that point at which pH of the solution becomes exactly 7 during the titration is called neutralization point of the titration. If you are doing titration acid base, okay, you can see here. First of all, we have taken in this case NaOH is base, okay, and after that you will add same amount of HCl, same amount of NaOH and same amount of HCl. That the concentration also will be same, okay, and strength is also same. We have seen in previous term. So the pH will be for this solution that is 7, right? That means in this case, if you will add same concentration, same volume of acid base solution, so you will get pH 7. Okay. Now next term that is suitable indicator. In this case, see the indicator which shows a color changes during the pH change in place at the valence point is called suitable indicator. And for example, you can take in a titration of strong acid and strong base. The pH change at the equivalence point is nearly 3 to 10 pH unit. And you can see the table. That table you can see 4 indicators are given. We know that the pH transition of that 4 indicators you can see between 3.1 to 10. Okay, that means it is near about 3 to 10. It means in these titrations all their indicators are showing their color changing action between this pH transition range. Okay, so all their indicators are suitable this kind of titration. And next term we have to see that is base indicator. In this case you can see a suitable indicator which has its transition range around the pH at the equivalence point is called the base indicator. And in this case, for example, see in a titration of strong base and weak acid, the pH at the equivalence point is 8.73. And you can see in this case again indicators which having different pH transition range. Okay, methyl orange indicators having 3.1 to 4.4 transition range. Okay, pH transition range, and methyl red having 4.2 to 6.3 pH transition range. Bromothiamol blue having 6 to 7.6 pH transition range, and phenolphthalein having 8.3 to 10 pH transition range. So in this titration, strong base and weak acid having 8.73 equivalence point, and you can see that pH transition range showing phenolphthalein indicator. That means this kind of titration, the phenolphthalein is the best indicator. Okay. So with the help of all these terms, we have to explain transition curves or titration curves. Okay. And they are divided into 4 types. That first one is strong acid and strong base. Second one is weak acid and strong base. Third is strong acid and weak base. Last one is weak acid and weak base. So all their types of titration curves we have to see in detail.